Alright, number 14. Abnormalities. In the 1980s, it was generally believed that congenital abnormalities affected about 5% of the nation's children. Some people believe the increase in the number of chemicals in the environment has led to an increase in the incidence of abnormalities. A recent study examined 384 children, found that 46 of them showed signs of abnormality. Is this evidence that the risk has increased? Well, let's look at this. What is P? P is the proportion of children born with congenital abnormalities. My guess is congenital means born with, but you guys are smarter than me. So you would know that better than I do. So we got that, and we know that P hat is 46 out of 384, which is what percent? 46. 11.97. So we're going to go with 12.0%. Okay, so what they're asking is, has it increased from 5%? Well, I would sure think so. I mean, it looks like it being 12%. But the question is, could this have happened by just random chance? This is part of the lesson here. Could this have happened by random chance? Or is the true percent of children born with congenital abnormalities actually more than 5%? Because if it is more than 5%, that actually would explain how you get a 12% sample. Okay, so let's do the test. So 1, we're going to look at the hypothesis. Age 0, P is equal to 0.05. The alternative, we want to see if it's great. Check to see if we have evidence that it's greater than 0.05. Conditions. 1, is it a random sample? Let's see, recent study examined 384 children, so it doesn't say that. So we're going to have to assume. That's why they call them assumptions, right? We assume it's representative of all children, right? Because if not, if they're taking a sample from people that live by a nuclear power plant or something like that, then obviously we wouldn't be asking this particular question about the whole population. So number 2, let's see, N is 384 is greater than 10%. My pen is not working too well. 10% of all children. Definitely true. And NP, 384 times 0.05 is certainly bigger than 10, and 384 times 0.95 is greater than 10. Okay. Does that make sense? Okay, Brady, put your hand down. 3. Mechanics. What do we do here at the mechanics? We want to find the z-score. What we're really asking is this question right here. It's amazing how I can do that with a straight face, yes? And that's the square root of 0.05 times 0.95 over 384. Okay, so here's my sample out here at 12. We want to find the probability that it's bigger than 12. Okay, so let's go right to there. I'm going to make this so it go smaller, yeah. Okay, so my z-score is going to be 12 minus 5 over standard deviation. And my p-value will be what? Well, I'm going to do this on my calculator, so I go to Stat, over to Tests, and down to 1 prop z-test. P0 is 0.05, first entry. X is 46, because we have 46 up here in my sample that had abnormalities. And N is 384. Now for the next line, it says prop, we want it greater than P0. So that's going to be the third one over. Calculate, and I get my z-score of 6.27. That's 6 standard deviations of above the mean. You think this is extreme? My p-value is 1.75 times 10 to the negative 10th, which is essentially 0. We can say approximately 0. Okay, so this makes the conclusion really easy. Okay. Since the p-value, approximately 0, is less than 5%, I have strong, extremely strong evidence that the true proportion of children with abnormalities is greater than 5%. Okay. All right. So does that make sense? I hope it does. But I asked you a question again. You can't answer it. So hopefully that explains it more. I know read the section of the books really explains a lot of this as well. So good luck with that.